Hi, good afternoon to everyone. Welcome to the show. Let me introduce myself first. My name is Khoo C G. I'm a functional safety engineer. Uh, Today I'm going to talk about a topic, what we call the process safety and reliability itself. Okay. Before we go into the topic itself, formality, let me do a quick introduction of IMI itself. Be careful there. Okay. Basically, we are from IMI. We work for IMI. IMI is actually an engineering company, and one of our motto is we wanted to solve the customer pain point, customer problem. We wanted to solve the problem of today, and we're going to take the challenge of tomorrow as well. This is where we actually start our company initiative as well. And we operate in a few sector, what we call sector. Predominantly, we are in the industrial automation, we are in the process automation. We are also in the business of climate control, building services, and life science plus transportation. This is where the terrain or sector that we are operating in. Okay. On the sector itself, I'm actually coming from the process automation side. So as the name explains itself, we are more active into the energy sector in the past, what we call the upstream, the downstream, conventional power, generation, petrochemical. We are also into the pharmaceutical, specialty chemical, industrial gas, and of late, everybody is also getting more and more involved and getting the more resource focus into the renewable or green energy segment as well. Okay, I'll jump right into the topics itself. Process safety and reliability. Why is it important about process safety? Now, in process safety, we are talking about dealing with chemicals, toxic, high pressure, explosive chemicals, and so on. All these processes involve a lot of risk as well. So what we wanted to talk about here is the process safety. We want to guard against any of the undesirable outcome. Okay. Ultimately, end of the day, we want to protect the life of the people and the environment. Should there be any mishap or undesirable outcome, we are talking about risk to the life and health of the people around it, not just the worker working in the plant, also people who are living around the environment as well. And of course, any mishap will mean there's an economical impact as well to the asset, whether it's the plant itself, damage to the facilities, and also to the reputation of the operator itself. We are talking about big companies that operate the Shell, ExxonMobil, all these are big operators. Their reputation is also at stake if any mishap. Okay. And last but not least, we are talking about efficiency as well. End of the day, any process, we are in the business of making money, productivity as well. So the efficiency of the system is also taken into consideration. By definition, when we talk about process safety, we are talking about proactively identifying what are the risks, understand what are the risks, and we prioritize the resource. You can identify a lot of risks, but not every risk is worth mitigating. Sometimes you need to strike a balance as well. So where is the risk? Prioritize what do we focus the resource into, and then how do we control it? What are the strategy we can use to control all these risks that we decided to handle? I mean, just during my training, one of the example illustrated by the trainer was, for example, in the zoo, the risk of a tiger escaping is very low, but the consequences of if that ever happened is quite terrible. So it's between the probability as well as the consequences as well that you have to manage. Okay, and ultimately we wanted the objective of giving a good or managing the process safety is we want to make sure that we minimize all these risks as much as possible. You want to avoid them totally if possible. So in this one simple word, we are talking about we want to identify what is the weakest link and how can we ultimately strengthen this weakest link. I think that is the whole gist of it. Now, in today's topic, I just want to focus on two areas of the strategy. There are many means, there are a couple of means of areas whereby you can actually mitigate all these risks. These include preventive testing, preventive maintenance, meaning to say you change out your pumps, you change out your seal every fixed period of time. One example will be your car. Every 6 months or 10,000 kilometers, you have to service your car, regardless of whether you use them or not. Now, that may not be the most efficient way of doing it. Redundancy system is one aspect that I'd like to discuss later on. Also, proactive testing of the system is another topic that I want to touch on later on. There are other areas, but because of today's topic, we won't be covering as well. Now, I'll talk about redundancy. I think the picture will give a better picture explanation. Imagine the person who is actually repairing the aircon. He is the guy who is doing the work. But the first guy, beside him, the middle guy, is actually a redundancy. No, he is a backup. The actual redundancy is the third guy. Imagine if the middle guy decided to walk away distracted by a phone call, what will happen to him? So you look at the lower picture whereby the welder that is doing the welding, this is a triple redundancy. You need 3 guys. Make sure that, our poor chap welder don't fall into the sea. So this is the concept of redundancy, safeguard against any unplanned or unforeseen circumstances. Now, how does this translate into instrumentation controls kind of redundancy we're talking about? So in functional safety terminology, there are broadly 2 types of random hardware failure. Hardware failure, there's a couple of hardware failures. One of them is random, you do not predict, you can't predict them. Okay, it could be a brand new installation and it will still fail. There are other type of failure like design failure, wear and tear after a long period of time, but over here we are focusing on random hardware failure, something that is not predictable. Okay. First type of failure, imagine there is an installation that maybe is critical valve that control crude oil into the refinery, for example. Now, in the event of a fire or what we call a safety demand, what we need is we want to be very sure that if there is a safety demand, you want to shut down the valve, you can be very, very sure that the valve will shut down. How do you be sure? I think end of the day, you need some redundancy, right? So this is one situation of failure, what we call a dangerous failure, sorry. It prevents you the plant to going into a safety state. And the consequences could be quite disastrous. It could lead to fire, explosion, loss of life, not to say the impact of the environment as well, and the damage of the asset, the property of the plant itself, and loss of production, which should maybe the last thing, because in terms of priority of importance. This is one type of failure, preventing the plant to go back to its safety state. There is another type of failure, which actually the plant went to its safety state undesirably. That means you didn't plan for it. It's what sometimes in convention term we call it unplanned shutdown. All mechanical engineering products have a lifespan, for example. If you have a solenoid valve or instrumentation, if the instrumentation for whatever reason come to the end of life, or maybe a lightning surge in electrical signal that shut down the system unintentionally, this is called unplanned shutdown. And the consequences may not be as bad as a dangerous shutdown in the top example that we're talking about. But it is also not desirable because it affects the production. And in some of the facilities, plant and all those things, you took a long time to start up. Not to talk about you need to do some root cause analysis and all those formality and investigation. So you lost production, you lost time, and you frustrate the production people as well. So these are the 2 types of failure that we think we are trying to talk about today, and we want to guard against this type of failure. In terms of terminology, we call this, sometimes if you are in the line, you'll hear the people in the field talk about 1 out of 2, 2 out of 2, or even 2 out of 3. What do we mean by this? This is basically, in simple terms, these are voting system. For example, the first one, 1 out of 2 is meant for safety. If I need to shut down the valve, if I have 2 backup systems to control the shutdown function, so long as one of the control systems say yes, shut it down, it will shut down. 2 out of 1. So you just like there are 2 systems, each have a vote. One of the systems say shut it down, the process will be shut down. This is to guard against the dangerous failure or what I explained earlier on, whereby the plant there is a fire, you want to be sure that it will shut down. Okay. The second one is 2 out of 2, meaning to say, in order to shut down the valve, you need both of them to vote yes. 2 of the backups, 2 systems to vote yes, then the plant will shut down. Now imagine if it's a 2 out of 2 and there is a fire, a real fire. One of the control system decided not to shut down. So the plant will not shut down. So that is a dangerous situation. So if you think harder, 1 out of 2 and 2 out of 2, basically these two concepts are actually contradicting each other. Okay? So like all engineering solution, we want to have the best of both worlds. That's why there's this thing called 2 out of 3. So instead of 2 votes, there are actually 3 votes. Majority wins. So long as 2 of them say shut down, it will shut down. So long as 2 of them say do not shut down, it will not shut down. So in a way, it's a voting system. Or in a way, you can consider this. The 2 out of 3 is a system whereby they can tolerate one of the control system that's malfunction. Whether they malfunction in the way that they want it to shut down or they don't want it to shut down. So it's at the end of the day, it's a majority win situation for 2 out of 3. So these are some of the safety systems. How do we translate them into circuitry? Basically, in terms of schematic, this is what it is. I just want to point out that from the safety, functional safety point of view, 1 out of 2 and 2 out of 3, what we call sales certified to level 3. Whereas 2 out of 2 is only sales certified to level 2 because it is not meant for safety, it is more meant for availability. You don't want to have the disruption to the production, that's all. Now our solution, now first of all, we didn't invent redundancy system. This is industrial practice and standard. But our solution, we propose something that comes in a manifold form. And you can see on the diagram on the right, let me bring in the bullet laser. The diagram on the right is a panel that before we have actually modified. You can see it's the same panel, both picture on the top and the bottom, they are the same panel. Before the retrofit, actually it took out about 2/3 of the footprint of the panel itself. But after retrofitting, the manifold is so compact, it actually took out only about 1/4 of the footprint itself. So in a way, it is compact, precise, and what is more important, we are talking about redundancy, we make sure there is no mistake in terms of setting up the configuration. You really don't want the fitter to join or connect the piping by error that you think you have a redundancy, but actually you do not have one. Some of the key features, all the components put into the redundancy system or in the manifold system that we are introducing today, actually by itself, we only use proven technology, product that has been in the market for many years. Okay, and they are all certified to sales standard. And for the offshore application, some of them, the stainless steel range are also complying to the NACE standard, whereby it guard against material fatigue and all those. And in terms of flexible configuration, we have many configurations for different requirements as well. It can be in a stainless steel, aluminum, it can be a 2 out of 2, 2 out of 3. We even have a feature what we call a bypass function, which I would like to take the chance to share a video with the team here to better explain what is a hot swap or bypass function.